Okay, Chapter 8-2 is solving systems of equations by substitution. Okay, example 1, we have two lines, x plus y equals 4 and y equals 2x plus 1. We want to find the solution for the system of equations, and that's where the two lines intersect. We're going to do this without graphing. What we're going to do is we're going to substitute. We have x plus y equals 4 and y equals 2x plus 1. We want to find which equation is an x equals or a y equals. And the first one is not an x equals or y equals, but the second one is a y equals. So it's y equals 2x plus 1. So that's telling us what y equals. Y equals 2x plus 1. We're going to substitute that into the y of the first equation. So now instead of y, we can put 2x plus 1. So x plus, and instead of y, we're going to put, instead of the letter y, we're going to put what y equals, which is 2x plus 1. Equals 4. And now we can solve for x because we only have one variable. So we're going to combine like terms. X plus 2x is 3x plus 1 equals 4. Subtract 1. You get 3x equals 3. Divide by 3. Divide by 3. And you get x equals 1. Okay, now that just tells us the first part of the point of intersection. That just gives us the x coordinate. We need to find the y coordinate. Okay, now to find what y equals, remember that part that we circled, 2x plus 1? Well, we know what x is. X is 1. So now I can just plug that in to find out what y equals. So that is, now I know that x is 1, y equals 2 times 1 plus 1, so y equals 2 plus 1, which is 3. So the y coordinate is 3. So the point of intersection is 1, 3. And if you plug in the 1, 3 into the first equation, you get x is 1 plus y is 3. 1 plus 3 is 4. So it works in the first equation. If you plug it into the second equation, 2 times 1 plus 1 equals 3. So seeing as it works for both equations, 1, 3 is the point of intersection for the two lines. Okay, example 2, the first line is 4x equals 3 minus y, and the second line is 8x plus 4y equals 6. We're trying to make one of them equal x equals or y equals, and it looks like it'll be easier to do that with the 4x equals 3 minus y. So what I'm going to do is bring the negative y to the other side so it becomes positive y, and bring the 4x to the other side so it becomes negative 4x. Okay, so now I have y equals negative 4x plus 3. Okay, so I brought the negative y to the other side, it becomes positive y. The 4x to the other side is negative 4x. So y equals negative 4x plus 3. And the second line is still the same. So we're going to substitute the y equals. It's saying that y equals negative 4x plus 3, so I'm going to circle that. I'm going to put that in place of the y over here. Since it says y equals negative 4x plus 3, wherever there is a y, we're going to put negative 4x plus 3. So 8x plus 4 parentheses, and I'm going to put in what y equals, which is negative 4x plus 3. Equals 6. And then we're going to do distributive property. So that's 8x plus negative 16x plus 12 equals 6. Okay, combine like terms. That's negative 8x plus 12 equals 6. We're going to bring the 12 over, that's subtract 12. And now I have negative 8x equals negative 6. Divide both sides by negative 8. And you get x equals negative 6 over negative 8, which is just positive 3/4. That's because negative divided by negative is positive, and if we reduce the fraction 6/8, it's 3/4. So we now have the first part of our point of intersection. We have the x coordinate, which is 3/4, and now we need the y coordinate. So you go back to what you circled, which is the negative 4x plus 3, and you're going to take the answer you got for x, which is 3/4, and you're going to plug it back in over there. Now we can find out what y equals because we know what x equals. So y equals negative 4 times 3/4 plus 3. Okay, the 4's cross cancel. We get y equals negative 3 plus 3, which is 0. So the point of intersection is at 3/4, 0.